This is Dr. B.D. Vaisuni, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In today's session, we will be learning about the moment of inertia from first principles. The course outcome of today's topic would be calculate moment of inertia and mass moment of inertia of a circular plate, cylinder, cone, sphere from the first principles. The topic covered would be moment of inertia from the first principles, and the topic learning outcome is understand the concept of moment of inertia and mass moment of inertia involved in practical engineering problems. First, let us see the moment of inertia of a rectangle by method of integration. This is the procedure where we will be identifying the moment of inertia of any regular shapes by using the basic principles. So, they consider the rectangular section of width B, which is given here. Width of the rectangular is B and the depth of D as shown in figure. This is the dimensions, or this is the area which is given for the rectangle, sizes which is given for the rectangle. Let B is the width of the section and D is the depth of the section as represented here. Now consider a strip of thickness dy. Here this is the strip which is being considered dy parallel to x-axis and at a distance of y. From it as shown in the figure. So the x-axis is passing through the center here of the rectangle and y-axis passing through the again center, which is the vertical axis. Therefore, the area of the strip is given as B into D into Y, nothing but length into breadth, right? The length into breadth. Length is taken as B and the depth is taken as dy. So, length into breadth B into dy would be the area of the strip. Now, what we are going to do, we know that the moment of inertia of the strip about x axis is equal to area into y square, that is distance of that objects from the reference axis. So that can be written as B into dy by into y square, that is equal to B into y square into dy. Now moment of inertia of the whole section may be found out by integrating the above equation for the whole length of the lamina, that is from minus dy to plus dy. What minus dy to plus dy represents? If at all we are considering the x-axis here, that if that is the origin OO which we consider, the total length of the square rectangle is given as d. So first half of the d would be d by 2 and second half of d would be again d by 2. If we consider this as the origin, this is the positive d by 2 and this would be the negative d by 2. That's the reason we are considering total minus d by 2 to plus d by 2. If we consider the total length height of this thing, then it will be becoming d by 2 minus d by 2 to plus d by 2. Hence, we will be obtaining the value as total d. Okay, that's how we are considering the values of length total d by 2 minus d by 2 to plus d by 2. As we are doing the solving the equation here with respect to the theorem, where we have considered the length from minus d by 2 to plus d by 2. Ixx, that means the moment of inertia of this lamina with respect to the xx axis can be written as integral minus d by 2 to plus d by 2 for b into y square into dy, that is equal to b into integral minus d by 2 plus d by 2 y square into dy. That can be simplified as b into y cube by 3 from d by 2 to d by 2, that is equal to b into d by 2 cube by 3 minus d by 2 cube by 3. That way, if you simplify this, you will be obtaining the value as bd cube by 12. Similarly, the Iyy value, which is the moment of inertia of this same lamina with respect to y-axis, is db cube by 12. Now, the moment of inertia about the base IAB. Previously, we have calculated the moment of inertia with respect to the axis, that is xx axis and yy axis. Now, if we need to identify the moment of inertia with respect to AB axis, then what we need to do? We can be applying the parallel axis theorem for obtaining the answer, right? So, with this, IAB can be written as Ixx, which is the moment of inertia of this rectangle with respect to xx axis, centroidal axis, plus area of the rectangle into h square, where h is the distance of this particular axis to the centroidal axis. Okay, So that where Ixx is the Ig, that is equal to moment of inertia of section about centroidal axis, and A is the area of rectangle, that is B into D. So H is the distance of center of gravity from the base, that is D by 2. Therefore, IAB is equal to BD cube by 12 plus BD into D by 2 square, that is equal to BD cube by 12 plus BD cube by 4 is equal to BD cube by 3. So IAB is equal to BD cube by 3. Similarly, moment of inertia of rectangle about the side IAC is given by the equation IAC is equal to DB cube by 3. This is about the moment of inertia calculation with respect to the centroidal axis as well as the side axis, where the reference axis can be considered using the parallel axis theorem. These are the basic principal methods for which we can identify the moment of inertia of any regular shapes. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.